So we're after break now. So the pink worksheet that you have should be week 14. That one's due this Friday. Okay. Is it 4 questions? Maybe some asymptotal and some end behavior type questions on the bottoms of them, but you have 4 questions there. Okay. This week is a summative quiz also. Okay. Summative quiz this week, Friday. Okay. We're kind of at that point in the semester where some of us need some more summative points to improve our grade before the end of the semester because we want grades up, not down. Okay. Yeah, and then we're still looking ahead to the week before winter break. That's only in 3 weeks. To 3.5 weeks is to have our test. So, warm up for you. So graph that one, and so remember you want to have your supplemental note sheet out too because that's always going to be helpful for you in doing this stuff. On anything. Yep. Back when we started, you can use it on formative, summative, and final. Yep. That's why I said you got to give me the front side. You can have the back side. We will be filling in another step on the supplemental sheet today too. So we agree with step number 1, that our domain is all real numbers, but x cannot be equal to 0, and therefore our vertical asymptote is x equals 0. Yes? On a graph, we would put that on the graph as a dashed line, up and down, right there. Agree with me so far? Mm-hmm. Without going any further, what also, it's a later step, what also got told to us just by that? There's no y-intercept. Why can't there be a y-intercept? Because that's where the vertical asymptote is, and we can't have anything on that vertical asymptote. So our y-intercept should be none when we get it. Okay? Right. Next one is our horizontal asymptote. What?
Y equals 2.
Y equals 2, because the degree on the top is 1, the degree on the bottom is 1, that's the same. So we go with coefficients. Y equals positive 2. That goes on our graph as a dashed line. Now from the couple of homeworks that I checked, those asymptotes, 1, need to be dashed, and 2 need to be on your graph. I will mark them wrong if they're not dashed or if they're not on your graph. Okay? Those are on there right from the start. We're not even anywhere near graphing yet, and they're already on. Okay? Next up, we have y-intercept, which we already said was none, because the y-intercept line is the y-axis, which is our vertical asymptote, so that's a none. If we didn't see that, we would plug in 0 for our x, and we would get negative 1 over 0, which does not exist. You can't divide by 0, so therefore it is none. Okay? X-intercept how do I solve for my x-intercept? Set my top, my numerator, equal to 0. So that would give me the point 1/2, comma 0. And then we just got to find more points in those spots, right? Okay. So we've got a zone over here. So let's go with -1. If I plug in -1, I get -2 minus 1 is -3 all over -1, which is +3. If I plug in -10, I get -20 minus 1 is -21 over -10, which is +2.1. So my left side of my graph comes in, goes up. Right side, I've already got 1 point there. So I could just go with +10. +10 is 20 minus 1 is 19. All over +10 is 1.9 is there. And so we come in down here and so. Oh, that's good. Huh? Then it said, talk to me about end and asymptotal behaviors. So based off of my graph, my end behaviors would be as x approaches positive infinity, my function was g of x this time. My function approaches 2 from below. Because I'm getting closer and closer to 2 when I'm on the below side of it. As x approaches negative infinity, my function approaches 2 from above. With me on those two. Need some refresher explanation as to the notation, what it's doing, where I find that. As we hear the discussion movement on third floor of the desks. Above us would be, that would be the 308 to 310. Okay. Asymptote behavior would be then as x is approaching 0 from the left, my function is going off to positive infinity, left side of the blue dashed line. And as x is approaching 0 from the right, my function is approaching negative infinity. Getting closer and closer to the blue line on the right side. It's going down. Questions, comments, concerns, clarifications? Fantastic. All right. So, today we're going to talk about if our function has what are called common factors. And if we have common factors, then we have a certain thing. So what I mean by that is, like if we had 6 over 8, we would reduce that to become 3/4. So 2 would be a common factor there. If we had something like x plus 6 over x plus 6 times x minus 1, then the x plus 6 would be a common factor, and we could reduce this to be 1 over x minus 1. If we had something like, I'm going to make one up, x squared plus 7x plus 10 all over x squared minus x. Does that work? Yes, minus x. Oops, nope, that's got to be minus 6. Minus 6. Okay? That has a common factor. What is it? like here, the common factor was we could divide both by 2, right? So 2 was my common factor. Here, we could divide both by x plus 6. So x plus 6 was my common factor. What do I got to do first in that third one? So 4. X squared is not the common factor. We've got to factor them first. What does the top one factor to be? Love it. What does the bottom one factor to be? I'll give you x mod. I'll finish the us. Minus 3 and x plus 2. So what's my common factor? X plus 2. So this one would factor to be x plus 5 over x minus 3. Yes, yes, yes. Okay? So that leads us all the way down here to our supplemental note sheet, where it says step number 0. We finally get to do step 0. Way up at the top, we get to fill that in. Okay? And so step 0 says the first thing that we have to do is we have to simplify. Okay? Which is great, because then that's going to make our graph easier to manage. Okay? So what we have to do is, and this is, I know this is a dreaded word for most people, but unfortunately, here in the maths, the F word shows up a bunch. Okay? We have to factor the top and the bottom completely. Okay? You got to factor it all the way until you can't factor it anymore. Which is why the unit before this is when we factor. Okay? Okay? So we got to factor the top, we got to factor the bottom. Now, if there is a same term in both the top and the bottom, you get to cross it out. What I mean by that is, like I'll go back up here to this one, where we said x plus 2 cancels out the x plus 2. We get to cross those out, and then this becomes our new function. Okay? Now, couple of things about this step 0. Okay? So the first thing about step 0 is your new factored function is used after step number 1. So you still use, I shouldn't say it, after, how do I want to say this? We'll say the domain part. Okay. So after you find the domain of your function, then you use your new factored form the rest of the way out. So for vertical asymptotes, you would use your new function. For horizontal asymptotes, you would use your new function. X and Y intercepts, new function. Step 5, which we're going to get today, new function. Step 6, which we're going to get on Thursday, new function. Step 7, extra points, new function. Okay? So the only thing that you use the original function for is finding the domain. Okay? So then after that, then we use our new function. So if something does factor out, now we're going to be on our new function, that leads us now then to step number 5. Step number 5 says we need to find the holes. So if something is factored out, in step 0, then we're going to set whatever it is that we factored out equal to 0. This is step 5 now, Loki. This is step 5. Yeah. Okay. So if something is factored out, we set that equal to 0. That whatever we factored out. So back in the example that we had, we factored out x plus 2. We would set x plus 2 equal to 0. Solve it. Okay? Then we're going to plug that value into our new function. And that's going to give us the y part of our whole. The setting it equal to 0 is going to give us the x part of the whole. And then we're going to plug that in, and that's going to give us the y part of the whole. That result is where you put a hole. And literally on your graph, you are going to put a hole. And so your function is going to look like this. And then it's going to have a huge hole in it. And then it's going to continue on. I'll get it. You're injured. Okay? Right? So your function is actually going to have a legitimate hole in it. And nothing's going to fill in that hole. Okay? You're literally going to have to lift up your pencil, go to the other side of your hole, and then continue on. If you draw through it, I'm going to mark it wrong. Don't draw through it. Huh? Here we go. So here's our function. Let's graph this bad boy. I went f of x. F of x equals x minus 2 over x squared minus 4 is our function. Step 0, we can say it now because it's in play. Step 0 says that I need to simplify if possible. So in order to do that, I first have to factor. Nothing can factor from the top. It stays x minus 2. Can anything factor on the bottom?
E.
E?
E.
Yes?
Yes.
Yes. Yes. What can the bottom factor to be?
X minus 2 and x minus 2.
X minus 2 and x minus 2?
X minus 2 and x plus 2.
And x plus 2. Yep. I like that better. Do I have a common factor? Yes. What is it? X minus 2. So x minus 2 cancels itself out, right? And I automatically think to myself, I've got step 5 in play now. Because I crossed something out. Okay? So my new function then, f of x, is going to be 1 over x plus 2. All right? So let's go. Let's do this. So my domain. For the domain, I go back to my original function. What are the two restrictions? All real numbers, but x cannot be, and?
-2.
2 and -2, right? Because 1 for each of them. Okay? That's it for my original function. With me? Now, I am looking solely at this function right here. For everything now, that function is my function. Okay? So what are the vertical asymptotes of this new function?
X
No.
Oh, no. X
No.
equals -2.
Negative 2. X equals negative 2 is the only vertical asymptote. Because I'm using this function now for everything after the domain. Domain, I use my original function. Everything after, I use my new function. Now, if nothing had canceled out, then there is no new function. Then it's just my original function, and I do it like we just did last. Okay? But something canceled out here. Okay? Horizontal asymptote. Do we agree with none? Who I know? What do you got? What do you got? Y equals 0? I like y equals 0. Y-intercept. 0, 1/2. X-intercept. There is none because 1 can't equal 0. All right, let's catch up on the graph. So we've got blue, -2 is there. Oops, I missed. We'll fix that in post. I missed again. Okay. Y-intercept of 0, 1/2 puts me right there. Good so far with everything. Okay. Step 5 now said we've got a hole. So we crossed out x minus 2. So I have to set that equal to 0. So that would give me x equals 2. So my hole is going to be at 2, something. Okay? Now I'm going to put 2 back into my new function. 1/2 plus 2. 2 plus 2 is 4. So this is 1/4. So I have a hole at 2, 1/4. So I go to those coordinates, 2, 1/4, and I put a hole, an open circle, right there on those coordinates. I circle those particular coordinates. Step 6 we don't have yet until Thursday. Step 7 says we have to come up with new points or more points to do. So let's go left side here. So we would have, I would go -3, maybe a -4, and a -10. Yeah? If I plug in -3 to my new function, -3 plus 2 is -1. So I've got 1/-1. That is -1. -4, I go 1/-2. That would be -1/2. -10 would be 1/-8. -1/8. So my function on this side through down here. Yes, sir. That was going to be my next question. Do I need to find more points on the right side? Maybe 1? Like -1? Like what the function is doing at -1? So if I plug in -1, I get 1/1. That puts me right there. Do I need any more? I don't think so. We've got 3, right? So it's going to come in through here. Now here's the kicker. Everybody pick your heads up and watch me. Okay? I get to here, and I lift up my pen, and I go to the other side of my hole, and then I continue on. Okay? Do not fill in that hole and make that hole so it is seeable. Okay? And that's the graph. Okay? So you find the hole by finding the coordinates of where you took something out of your function. Okay? Now, earlier, somebody had said, I don't remember who, but somebody had said when we were finding vertical asymptotes, that the vertical asymptotes would be at +2 and at -2. Okay? This, by factoring out that factor, that took out that x equals +2 vertical asymptote and replaced it with a hole. Okay? With me? Awesome sauce. Let's factor first, and then we need to graph. Okay? So let's get it factored together, and then I'll let you guys graph it by yourself. Okay? Anything factor from the top?
No.
No. Okay, so that's going to be x plus 6. Does the bottom factor? To what? X plus 6 and x minus 1? I would concur. Do I have a common factor? Yes. What is it? X plus 6. So my new function is going to be what? Okay. So with that being said, you graph that one and find me all of our stuff. All right. So our domain is going to be all real numbers, but x cannot equal -6 or +1. Because I go back to my original equation for that. Okay. Now from here, I'm using just that one. So my vertical asymptote is x equals +1. My horizontal asymptote is going to be y equals 0. My y-intercept is going to be 0, -1. If I plug in 0 for x, I get 1 over -1, which is -1. My x-intercept is none, because 1 cannot equal 0. With me on all of that so far? Then, because I factored out x plus 6, I set that equal to 0, and that gives me x equals -6. Then I need to find my new f of -6. Which would be that. So my hole is at the point -6, comma, -1, 7. 1 and 2 and 3 and 4 and 5 and 6, -1, 7, right there. Personally, I don't feel that we need to find any more spots on this side. Gets me there? Just got to do the other side. So we would do like 2. If I plug in 2, then I'm at 1 over 1, which is 1. If I would do 3, then I would be at 1/2. And if I did 10, I would be at 1. Okay. Questions, comments, concerns, clarifications? Need a little bit more explanation. All right. So, just based off of this one, okay, off of this function, not graphing this one, just based off of it, find me any intercepts, any asymptotes, and any holes. So, we would need vertical asymptotes, horizontal asymptotes, my y-intercept, my x-intercept, and if there's a hole. Okay? Go for it. Not graphic. Over -4 would be positive 9/2. That's what I got. Vertical asymptotes come from the downstairs, right? So x squared minus 4 factors to be x plus 2 and x minus 2. So that's where I got my 2 vertical asymptotes from. Horizontal asymptote, we have a degree of 2 on the top. We have a degree of 2 on the bottom. So we're going with coefficients. Lead coefficients are 2 over 1. So that's just 2. My y-intercept, I just basically get rid of any term with an x in it. So I've got 2 times -9, which is -18, over -4, which reduces to positive 9/2. X-intercepts, I take the numerator and I set it equal to 0. Well, it factors to be that, so it's got to be positive 3 and -3 to make those be 0. And there's no common factor, so nothing cancels out. Okay? Questions, comments, concerns, clarifications? Your homework this week is week 14, the pink worksheet. You can do all of it